Hello everyone, I am going to explain question number 5, question number 6 and question number 7 of exercise 2.1 of class 12. So we will start from question number 5a. We have to differentiate it with respect to x. So whatever function is available, we will assume this complete function as y. So y equal to sin inverse 1 plus x square upon 1 minus x square and cos inverse 1 plus x square upon 1 minus x square. Now before differentiating it, if we can reduce it into the simplest form, we should. So when we observe it, we found that it is in the form of sin inverse theta plus cos inverse theta equal to pi upon 2. So if the values are same, then it's going to be pi upon 2. That's why the value of this sin inverse to this cos inverse is going to be only pi upon 2. Now differentiate it with respect to x. So since it's a constant, so differentiation of constant is 0. Hence the A part of 5th is completed. Now we'll start from the B part of question number 5th. In B part we have the function like this. So we'll assume this complete function as y. So that is our equation first. So this is our equation first. Now here, since here is also cos inverse and here also cos inverse, so take cos 2x as cos theta. So here you have to take care that complete this 2x we have to assume as cos theta. So cos will remove here, so it's going to be cos inverse 2x is equal to theta. Now we do the replacement in equation first. So in equation first, instead of this 2x, we are going to write down cos theta because we assumed here. Now this 4x square we can write as 2x square, that is 2x value is cos theta. So here instead of 4x square, what will come? Cos square theta. So we had done the replacement here. Instead of 2x, cos theta, and instead of 4x square, cos theta square. Now here cos and cos will remove each other. We will get here only theta, and root 1 minus cos square theta from this identity is sin theta only. But here is cos. We can't remove them. That's why convert this sign in terms of cos by complementary angle formula. So this sin theta we can write as cos pi upon 2 minus theta. So now this cos and cos will remove. So you will get this theta as it is. Now this cos and cos will remove. So 2 and this small bracket remain here. Now open them. When you will open it, 2 will multiply by both. That will give you pi minus 2 theta. Now this minus 2 theta and plus theta is becomes minus theta. Now replace theta from equation second, that is theta value is cos inverse 2x. Now differentiate this complete equation with respect to x. So derivative symbol will come with this y and derivative symbol will come with both the terms. Now since it's a constant, so its differentiation is 0. Now cos inverse theta's differentiation formula is minus 1 upon root 1 minus theta square. So here we will assume this complete as theta. So it's going to be minus 1 upon root 1 minus theta square. But it's not simplest form of x, so we have to apply the chain rule. That's why this derivative symbol will go with 2x also. Now again we will differentiate it. Now just see, 0 I wrote as it is, we should neglect it. Now minus into minus is plus, and this 2x square when we solve we will get here 4x square. Differentiation of this 2x is only because it's coefficient, so 2 will come in front, and differentiation of x is 1. So 2 into 1 is 2, and that 2 into 1 is again 2. So that is the 5th part B completed. Now we will move to question number 6. Question number 6 is find the derivative of given function with respect to x. So this question is very different. So by observing them, we can see here we have two variables a and x, and we have to differentiate it with respect to x. So here when we observe them carefully, we can see that if we will replace this x by tan theta and this a by tan alpha, then after replacement it can come in the form of tan theta plus alpha formula. So to bring them in the form of tan formula, we replace this a and x in terms of tan. That's why This x we had assumed as tan theta and this a we had assumed as tan alpha. From here this tan will come here, so we will get theta is equal to tan inverse x, and from here we will get alpha is equal to tan inverse a. Now we will do the replacement. Whatever we assumed, that is x is tan theta and a is tan alpha, we will do the replacement here. After doing the replacement, we observe that it came in the form of tan alpha plus theta, because we know this formula, that is tan x plus y is tan x plus tan y upon 1 minus tan x tan y. So with the help of this formula, we obtained that this complete term is converted in the form of tan alpha plus theta. So that is importance of this question, that by observing these small bracket, we have to judge that how we can convert it in the form of tan. So that will give you into your mind that we should assume this x and a as tan form. That's why tan theta as x and a as tan alpha. Now this tan and tan will remove each other, so we are remained with alpha and theta. That we do the replacement, that alpha is tan inverse a and theta is tan inverse x from equation second. Now we differentiate it with respect to x. So derivative symbol will come with all three. Now since this a is constant, because student we are differentiating with respect to x, so except this a variable, other all variables are going to be constant for us. So this tan inverse a is constant, so the differentiation of constant is 0. Now tan inverse x differentiation is 1 upon 1 plus x square. That's the answer of A part of question. This question. Now B part. Find derivative of given function with respect to x. So here we'll assume this complete function as y. Now we'll try to simplify it. So it is in the form of a to the power m plus n, that we can write as a to the power m multiplied by a to the power n, means you can open this power, so this base will split, so it's going to be 2 to the power x multiplied by 2 to the power 1. Now this 4x square we are going to write as, this 4 we are going to write as 2 to the power 2 and this x as it is. Now in further step, 2 to the power 1 we can write as 2 dot and 2x square 2x. Now here, since these powers are, when we'll open the small bracket they will come in multiply, means we can exchange the power, so x will come inside and 2 will go outside, so we can write like this. Now why we have done this, because we are going to replace this 2x as tan theta, so that's why this question is also very important and unique, very important question. Frequently it used to come in board exam, that's why you should take care that in these kind of question, this 2x complete we have to replace by tan theta. So you have to bring in numerator as well as in denominator anyhow 2x. That's why we have done these steps. Now we will assume 2x as theta. From here, if you want theta, this tan will come here, so it's going to be tan inverse 2 to the power x. Now we'll replace here, wherever 2x is there in the equation, first we'll replace it by tan theta. So after replacement, what will come here? 2 tan theta, and here it will come tan square theta. So see this replacement. Now it is the formula of tan 2 theta. Since it's the formula of tan 2 theta, so we replace. Now tan and tan will remove each other, so we will obtain here only 2 theta. So this theta from equation, from here equation second, theta is tan inverse 2 to the power x. So we wrote here. Now we are going to differentiate it with respect to x. So when we differentiate it with respect to x, derivative symbol will come here also and here also. So this 2 is coefficient, so it will come in front. We have to differentiate it. So it is tan inverse 2 to the power x. So tan inverse x formula is 1 upon 1 plus x square. So when we differentiate it, we will assume it as x. So what is the formula of differentiation of tan inverse x? 1 upon 1 plus x square. That's why it came 1 upon 1 plus x square, means 2x to the power 2. But it is not x. So we have to use the chain rule. That's why we have to differentiate it again. That is 2 to the power x we have to differentiate. Now 2 to the power x, to differentiate it, we are going to use this formula a to the power x log EA. So 2 to the power x, that is ax, then log E2 That's why from here this formula it came. Now here what we had done is, again we had exchanged this x and 2, so it came like this. And here in numerator you just see this 2 and its power is 1, and this 2's power is x. Now both are in multiply, so you know the formula from the small class. A to the power m multiplied by a to the power n is a to the power m plus n. So here power is 1, so it's going to be 2 to the power 1 plus x, that is x plus 1. Now this log e to just write as it is. Now here we exchange the power. Now 2 to the power 2 is 4. Means this we are done to arrange the question. Now this in differentiation, integration, every time the base is going to be e only. That's why you can avoid, no need to mention it. So that's the answer. Now the question number 7th. Find the derivative of given function with respect to x. So we assume this as equation first. Here instead of x, just assume as cos theta. That will give you. Now here in this question, don't replace this cos here to bring cos inverse x. From here just find out sin theta, because in future we need sin theta value. So if x is cos theta, then what is going to be sin theta? From this identity, sin theta is root 1 minus cos square theta. So cos square theta is x square. From here we will replace the value of x. So this value I calculated because I need afterwards. I hope it's clear to you. Once again I am repeating, x will assume as cos theta. We need this substitution, and from here instead of finding cos inverse x as theta, I calculated sin theta because I knew that after that we need it. Now we'll replace here, instead of this x we'll replace cos theta. After replacement, the question is going to be like this. Now 1 minus cos square theta is 2 sin square theta by 2, and 1 plus cos theta is 2 cos square theta by 2 by this formula. I already explained this in previous question how it came. Now this 2 and 2 will cancel, and sin square theta upon cos square theta is 10 square theta by 2, and 10 square and this root will cancel, so we get only here 10 theta by 2. Now this 10 and 10 will remove each other, so we will get only theta by 2. Now 2 and 2 will also remove, so we will get here only sin theta. As we calculated already sin theta as root 1 minus x square. Now we will differentiate it. So when we differentiate, I wrote it in the form of power. Why? Because I am going to use the formula of differentiation of x to the power n, that is n x n minus 1. So here what is n for us? 1 upon 2. So n, that is 1 upon 2, this complete as x n minus 1. Then differentiation of, because it's not the simplest form of x, so we have to use the chain rule until the differentiation symbol should reach to the innermost function, that is x square. I hope it's clear how we differentiated. We differentiated it with by assuming it as x to the power n. So x to the power n formula is, differentiation formula is n x n minus 1. Then differentiation of the inner function again by the chain rule. Now half minus 1 is minus half. When we differentiate it, one differentiation is 0 and x square differentiation is 2x. Now this minus half is going to be upon root 1 minus x square, and this minus 2x and this 1 will multiply. Now 2 and 2 will cancel, so you will get here x upon root 1 minus x square. So how we have solved this? Once again just see, because this thing is new for us, that's why you should take care that after assuming x as cos theta, we have to calculate the sin theta. If you forget, then also after reaching to this step, automatically will come in your mind that we have to use this format. So then after here also you can solve. Now we'll move to the next question of the same, question number 7th, B part. So B part is this. So here is cot inverse x. So we'll assume it as tan theta. After assuming it as tan theta, 10 will come here, so it's going to be tan inverse x. So when we replace here root 1 plus x square, so root 1 plus tan square theta is sec theta, and here tan theta. Replace them in sin and cos. So that will give you like this. Take the LCM. Now here student, we need here cot, because cot inverse we have, and anyhow we need here cot. So to bring in the cot, we can't use directly any formula, so we'll change this sign in terms of cos. So it's going to be cos pi by 2 minus theta. By complementary we changed here. Now this cos theta also changed in terms of sign. Now 1 plus cos theta formula is 2 cos square theta. Now I explained here properly, because student cos 2 theta formula is cos square theta minus sin square theta. That's why instead of 2 theta, if pi upon 2 minus theta come, that time what is going to be, because when 2 theta is there, half of 2 theta is theta. So half of it, when you will do half of it, is going to be pi upon 4 minus theta upon 2. So cos square pi upon 4 minus theta by 2, and here sin square pi upon 4 minus theta by 2. So from here, when you will solve, you will get 2 cos square pi upon 4 minus theta by 2 is 1 plus pi upon 2 minus theta. That's why 1 plus cos pi upon 2 minus theta is 2 cos square pi upon 4 minus theta by 2. Now here down you just see the formula of sin 2 theta is 2 sin theta cos theta. So when 2 theta is here, that time what we obtained here, half of 2 theta, that is only theta. So instead of 2 theta, if we have pi upon 2 minus theta, then half of it, when you will do half of it, it is going to be pi upon 4 minus theta upon 2, and here also pi upon 4 minus theta by 2. So we can replace sin pi upon 2 minus theta by this term. So here instead of sin pi upon 2 minus theta by 2, we use sin 2 theta formula, that is 2 sin theta cos theta. I hope this step is clear by these formulas. Now this 2 and 2 will cancel each other. This 1 cos and cos will cancel each other. So cos upon sin is cot. Now cot and cot will remove. Now we are remain with pi upon 4 minus theta upon 2. Now theta will replace, that is tan inverse x. Now we differentiate it. It's a constant, so its differentiation is 0, and tan inverse x differentiation is 1 upon 1 plus x square. That's the answer. So students, in this question, these formulas are very important. So try to understand and learn them. So hence this question is completed. Thank you.